Hey, 30-2s. Welcome to your lesson on looking at the graphs of sinusoidal functions. So what we're going to learn in this lesson is how we relate the equation of a sinusoidal function to the graph and vice versa. Okay, so make sure you've got your graphing calculator with you because you're going to need it. There's a bit of an investigation for you to do here. Okay, let's take a look. So here's what we're going to do in this lesson. Is we're going to relate our equation, which is written in this form, to the graphs. And so we need to figure out what A, B, C, and D all do and how they relate to the graph. Where we're actually going to start is we're not going to start with the A value. In fact, we're going to start with the D value. And that's where I always want you to begin. Okay, so the first thing we want to look at then is just a normal graph of sine x. So here is the graph of sine x. So if you wanted to grab your graphing calculator, what you need to do is you need to remember we're always in radian mode. And you could change your window settings by going zoom trig. And you would see this graph right there. Now, a couple of things I need you to know. I need you to know that this graph doesn't really have a starting spot or an ending spot. It goes on forever. It's called periodic. But we'll say that this graph begins at 0. And if you notice, it starts, if we follow along here, it repeats at 2 pi. So that's known as the period, or 6.28. The amplitude is how much up and down we go from the middle. Well, the middle of this graph is right here. That's called the median line. Think of median as the middle of the road, right? The middle or the average. So that's that line there. And the amplitude is how much up and down we go. This distance or this distance here. Well, up and down from 0 is 1. Now the horizontal shift I'll talk about in a little bit, but for now, don't worry about it. Okay, so let's take a look. We're looking at the D value here. Well, if we look at our next graph, I want you to notice that the D value is 1. That's our D. D is equal to 1. Well, how did that change our first graph into the second graph? Okay, so here's what I'm going to look for. First thing I want to notice on this graph now is that the middle of my graph is right there. It's at 1. Guess what? Y equals 1 is my median line. Plus 1. Maybe we figured this out already. I noticed that the amplitude, the period, and the horizontal shift haven't changed. Okay, so what we're starting to see already is that this D value is going to move our graph up and down. So on this next one here, it says -1. So D is -1. So what this is going to do is it's going to give us this imaginary line in the middle of our graph like this. And then nothing else is going to change. So our amplitude is still going to be 1. So here I'm just going to draw in this imaginary line here. That's how far up my graph is going to go. It's also going to go down 1, just like that. And now I can draw this graph. It's going to start right there on the y-axis. It's going to repeat at 2 pi. Halfway in between, it's going to be at pi. And so this graph is going to look like the one above it, just it's going to be shifted down 1 unit. So our midline or median line is at -1. Our amplitude will still be 1. Our period will still be 2 pi. And we won't have been moved horizontally. So what does the D value do for us? When a sinusoidal equation is written in this form, the D value represents how far up and down this graph is moved. That's called the vertical translation or vertical shift. For us in 30-2, we normally think of this as the median line. Okay, when we get to applications, you're going to hear me refer to this as the average line. So it moves the curve up or down d units. This is the first thing I always want you to find, and I'm begging you to draw this in your graph. Okay, there's the d value. Now, we're going to skip over to the a value. So again, let's look at our original graph of sine x. Well, our original graph of sine x, again, here's all our information, just like that. Look at our second graph here. This graph has an a of 2. Well, really, the first graph had an a value of 1. What do you notice about these two graphs? Well, if you look at the second graph, first thing I want you to notice, the median line or the midline is right there, still at 0. But now what I want you to notice is this amplitude, this distance from max to median or from min to median is now 2. Huh, okay. Period. Period is how long it takes for my graph to repeat. Well, it starts over here at 0. It repeats at 2 pi. Period is still 2 pi. And again, don't worry about this phase shift or horizontal shift for a while. Okay, well, if you figured it out, then the only thing that changed was the amplitude, and the amplitude is the same as my a value. My a value is my amplitude. Now it's convenient because a amplitude. So what would this next one look like? So first thing I want to notice is there is no d value, it's 0. So I draw that line in. Then I notice my amplitude is 3. So I'm going to go up 3. So I'm just going to draw on an imaginary line for how far that graph would go up. I'm going to draw on an imaginary line for how far that graph will go down from the median. And now I can draw my graph. It starts at 0. It repeats at 2 pi. Halfway in between, it's right there at 0. And here it is. Okay, so my amplitude on this one would be 3. My midline would be 0. My period is still 2 pi. And this weird horizontal shift I'll talk about in a few minutes. So what you should gather from this is that the a value represents the amplitude. This is how much the curve will rise and fall a units above the median line. Another way to describe this is how much it will vary from the median line. All right, so we've done D. It moves us up and down. And the a value is how much we're going to vary from that d value. Okay, D and A done. They're the easy ones. The trickiest one for us in 30-2 is what we're going to do next. We're going to look at the b value. So on our original graph, our b value would be right here. It's a 1. Well, we know that this isn't affecting the midline, and we know this isn't affecting the amplitude. So it's one of these last two. So let's take a peek here. The next graph, the b value is 2. Well, what did that do to the graph? Well, what I want to notice here is my period. I started at 0, but now I repeat at pi. There is my period. If I look at the graph above, I started at 0 and I repeated at 2 pi. That was my period. So the b value is related to the period. The period is now pi, or 3.14 if we're going to truncate it. So the b value helps us find the period. Do you notice the b value is not the period? The period's not 2. It helps us find the period. So how does it help us find the period? Here's how this works. So let's look at the last one. I notice here the b value is 4. There's nothing else there. So I know my vertical shift, or my median line, is still 0. My amplitude is 1. Again, don't worry about the horizontal shift. We'll do that in a minute. Here's how this works, friends. The period of my graph is going to be 2 pi divided by b. What? Well, come look at this last one here, or the one before. 2 pi divided by b. Well, in this case, it's 2 pi divided by 1, which is 2 pi. This graph, it's 2 pi divided by 2. 2 pi divided by b. Well, 2 pi divided by 2 is pi. So this graph here will be 2 pi divided by 4, or pi half. 2 divided by 4 is a half. So what will this look like? Well, this one's actually going to be not so much fun to draw. The graph starts at 0, but now it's going to repeat at pi half. So this graph is getting really, really squished. So what this graph is going to do is, if you graph this in your calculator, it's going to look like this. See how squished it's going to be? And then it will repeat every pi units. So if you put that thing in your calculator, it's going to get really, really, really squished. Every pi half units, this thing is going to repeat. So the b value changes the length of the period. It is not the period, okay? It changes the length of the period. It expands or compresses horizontally. What I need you to know is the period is equal to P is equal to 2 pi divided by B. And this, my friends, is on your formula sheet. So if you scroll down on your formula sheet, there it is, right there. Okay, we're doing well. So we've got all sorts of things figured out already. We've got A, B, and D. The last one we got to figure out is C. Well, C in 30-2, the C value is not a big deal. Here's all I need you to know. So if I look at the second graph here, I see this C value is plus pi half. Well, I want you to notice that originally a sine graph starts at 0 on the median line. But now if I draw my median line in, this graph isn't starting at 0, it's starting over here at negative pi half. That value right there. So all I need you to be able to tell me in 30-2, I don't even need you to tell me the value that it's been moved left or right. I simply need you to say yes or no. So as soon as I see a C value, so like on this next one here, what this would do is it would actually move our graph pi half to the right. Friends, I'm going to say this again. I don't need you to actually tell me that value. I simply need you to answer yes. That's it. Okay. Nothing else would change here. D value is 0, so median line is 0. A value is 1. B value is 1, so this is going to be 2 pi. Okay. What this graph would do is it would look something like this. Okay. So again, I don't need you to tell me anything about that C value other than yes or no. So the C value moves the curve left or right. That is the starting point's move if there is a C value. The question will always be simply yes or no. Has the graph been moved? Okay. This is all summarized right here for you. So when a sinusoidal equation is written in this form, here's the order that I want you to analyze it. The first thing I want you to do is define the median line. That's your D value. Then I'll find my amplitude. That's my A value. Then I'm going to find the period, or the B value, and I'm going to use this formula that's on my formula sheet. And remember, for number 4, the horizontal shift is simply the C value. Okay, so here's the steps. Find the midline. Draw it in, please. Find the amplitude. So how far up and down do I go? Determine the period. And if you know the period, then you can find the B value or vice versa. And the C value, you start by looking at the midline and see if we start on the y-axis or not. So here's how this goes. Here's just a random sine graph that I've drawn. So in order, what I'm going to do is I'm going to find this value right here. I'm going to draw it in. So that would be D is equal to 3. Amplitude. Well, amplitude, I'm simply just going to count up and down. So I just draw in from my median line or my midline up and down. Well, that tells me it's 2. Just like that. My period, well, the period, there's a whole sorts of different ways that we could find the period. I could go from minimum to minimum. That's a period. I could go from median or midline intercept to midline intercept. That's also a period. I could go from max to min. That would be half a period, and I would multiply that by 2. So there's tons of different ways to find the period. So on this graph, friends, I'm going to go from minimum to minimum. Well, this over here is at negative pi half. This one over here is at 7 pi divided by 2. So the period of this thing is how far to go from negative pi half to 7 pi half. Well, that period is going to be 8 pi over 2 or 4 pi. Okay, so you can see the order in which we're going to do these things. The C value again would just be yes or no. So the C value, I'm going to say, look, here's my median line. Here's where my graph starts going up for the first time. So this graph has been moved. I'm going to answer yes. Okay, friends, there is how we look at the graphs and the equation. In the next lesson, we're just going to work on this just a little bit more. Okay, I will see you next time.